Saturn is probably my favorite planet other than Earth, and I think you'll agree with me at the end of this movie because the Cassini mission has given us some amazing imagery of this beautiful world. I'm excited to show you the magnificent planet Saturn today. Before we begin, please like and subscribe to our YouTube channel. The second largest planet in our solar system, Saturn is a gas giant with an average radius around 9 times that of Earth. Its equatorial and polar radii differ by roughly 10%, which is why I say average radius. It has a 60,000 kilometers circumference. I'll discuss some of the stunning Cassini photographs in this video, as well as give a broad summary of practically everything you could ever want to know about the sixth planet from the Sun. A great white spot, a rare yet transient event thought to happen once per Saturnian year, is produced by the planet on average every 30 to 40 Earth years. If there is a 30-year pattern, we have seen a handful of them over the past 30 years. Despite the fact that another one is imminent, we will regretfully only be able to observe it through the Hubble Space Telescope because the Cassini mission terminated a few years ago. Saturn also contains a lot of smaller storms, where lightning frequently occurs. While this may seem feeble, Cassini has even heard thunder. You are actually hearing the audio version of the radio waves that lightning created. As we continue our discussion of storms and get to the planet's poles, we discover that each pole has enormous permanent storms. In truth, lightning on Saturn is around 1,000 times more powerful than that which we observe on Earth. In November 2006, NASA stated that Cassini has seen a hurricane-like storm bound to the South Pole with a distinct eyewall. It was the first time that eyewall clouds have been observed on a planet other than Earth. The second largest planet in the solar system after Jupiter, Saturn is located 6 planets from the Sun. With a typical radius of almost 9.5 times that of Earth, it is a gas giant. Saturn is nearly 95 times more massive than Earth, but having only an eighth of the average density. The core of Saturn's interior most likely consists of silicon and oxygen compounds, or iron, nickel, and rock. Its outer layer is made up of gas, followed by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen, and a layer of liquid helium. Saturn's upper atmosphere contains ammonia crystals, which give the planet a faint yellow tint. It is hypothesized that Saturn's planetary magnetic field, which is weaker than Earth's yet has a magnetic moment 580 times that of Earth due to Saturn's bigger size, is created by an electrical current within the metallic hydrogen layer. The magnetic field strength of Saturn is roughly 1/20th that of Jupiter. Although long-lived structures can be seen, the outer atmosphere is typically monotonous and lacking in contrast. In comparison to Jupiter and Neptune, Saturn has wind speeds that can reach 1,800 kilometers per hour. The planet's large ring system, which is primarily made up of ice particles with a little amount of rocky debris and dust, is its most distinctive characteristic. There are hundreds of moonlets in Saturn's rings, as well as at least 83 confirmed moons orbiting the planet, 53 of which have official names. The only moon in the solar system with a significant atmosphere is Titan, Saturn's largest moon and the second largest in the solar system. Titan is larger than the planet Mercury despite being less massive. The Roman deity of agriculture and prosperity, Jupiter's father, inspired the name of Saturn. Its astrological symbol can be found in the Greek Oxyrhynchus papyri, where it is an abbreviation for the planet's Greek name, Ochronis. It is a Greek caparo with a horizontal stroke. In order to Christianize this pagan emblem, a cross was placed to the top in the 16th century, giving it the appearance of a lowercase Greek eta. The seventh day of the week, Saturday, was given the name Saturn's Day by the Romans in honor of the planet Saturn. The main components of the gas giant Saturn are hydrogen and helium. Although it lacks a clearly defined surface, it probably has a sturdy core. Due to its spin, Saturn is an oblate spheroid, meaning that its equator bulges and its poles are flattened. The distance between its equatorial and polar radii, 60,268 kilometers against 54,364 kilometers, is over 10%. The other giant planets in the solar system, Jupiter, Uranus, and Neptune, are similarly oblate, albeit to a lower degree. Because of the bulge and rotation rate, the effective surface gravity near the equator, 8.96 meters per square second, is 74% lower than the surface gravity of Earth and is lower than that at the poles. The equatorial escape velocity, which is almost 36 kilometers per second, is significantly higher than the Earth's. Even though Saturn's core is significantly denser than water, the planet's average specific density is 0.69 g/cm3 due to the atmosphere, making it the only planet in the solar system that is nearly 30% less dense than water. Saturn is 95 times as massive as Earth, while Jupiter is 318 times as massive. Saturn and Jupiter make up 92% of the solar system's total planetary mass. Even though hydrogen and helium make up the majority of Saturn's mass, most of it is not in the gas phase due to the fact that hydrogen becomes a non-ideal liquid when its density exceeds 0.01 g/cm3, which is attained at a radius where 99.9% of Saturn's mass is concentrated. Saturn's interior experiences a steady increase in temperature, pressure, and density as it moves closer to its core, turning hydrogen into a metal in the uppermost layers. According to conventional planetary models, Saturn's interior resembles Jupiter's, with a small rocky core encircled by hydrogen and helium and containing minute amounts of various volatiles. Saturn is far more centrally condensed than Jupiter, and as a result, the area around its center contains a significantly greater amount of material denser than hydrogen, according to analysis of the distortion. By mass, Jupiter's center regions have about 67% hydrogen and Saturn's central regions have about 50% hydrogen. The composition of this core is comparable to that of the Earth, although it is denser. Physical intermodels and analysis of Saturn's gravitational moment have made it possible to set limits on the mass of Saturn's core. According to calculations made in 2004, the core must be 9 to 22 times the mass of the Earth and have a diameter of around 25,000 kilometers. Saturn's rings measurements, however, point to a far more diffuse core with a mass of about 17 Earths and a radius of roughly 60% of Saturn's total radius. A thicker liquid metallic hydrogen layer surrounds it, followed by a layer of helium-saturated molecular hydrogen that progressively turns gaseous as altitude rises. Gas makes up the 1,000 km long outermost layer. Saturn emits 2.5 times more energy into space than it receives from the Sun and has a heated interior that reaches 11,700 degrees Celsius at its core. The Kelvin-Helmholtz mechanism of slow gravitational compression produces Jupiter's thermal energy. However, because Saturn is less massive than Jupiter, this mechanism could not be enough to explain how heat is produced there. A different or additional process for producing heat could be the raining out of helium droplets from deep inside Saturn. The mechanism causes friction to produce heat as the droplets move through the lower density hydrogen, depleting the helium in Saturn's outer layers in the process. It's possible that these falling droplets gather to form a helium shell around the core. Diamond rain has been hypothesized to fall on Saturn, Jupiter, Uranus, and Neptune, as well as the ice giants Uranus and Neptune. 96.3% of the molecules in Saturn's outer atmosphere are hydrogen atoms, and 3.2% are helium atoms. In comparison to the quantity of this element in the Sun, the fraction of helium is greatly inadequate. Although the specific number of heavier than helium metallic elements is unknown, the proportions are thought to approximate the primordial abundances from the solar system's origin. According to estimates, the total mass of these heavier elements ranges from 19 to 31 times that of the Earth, with a sizable portion concentrated in Saturn's core area. The atmosphere of Saturn has been shown to include trace amounts of ammonia, acetylene, ethane, propane, phosphine, and methane. The lower-level clouds appear to be either ammonium hydrosulfide or water, whereas the top clouds are made up of ammonia crystals. Methane is photolyzed by the sun's ultraviolet light in the upper atmosphere, where it undergoes a sequence of hydrocarbon chemical processes that are then moved downward by eddies and diffusion. The annual seasonal cycle of Saturn influences this photochemical cycle. Similar to Jupiter's atmosphere, Saturn shows bands, although Saturn's bands are much fainter and are much wider around the equator. These bands are referred to using the same terminology as those on Jupiter. It wasn't until the Voyager spacecraft's flybys of Saturn in the 1980s that the finer cloud patterns were discovered. Since then, telescopy from Earth has advanced to the point where routine observations are now possible. Over 1.4 billion kilometers separate Saturn from the Sun on average. With an orbital velocity of 9.68 kilometers per second, Saturn completes one round of the Sun every 10,759 Earth days, or approximately 29 plus 12 years. As a result, it joins Jupiter in a nearly 5:2 mean motion resonance. Saturn's elliptical orbit is 2.48 degrees inclined with respect to the Earth's orbital plane. Average perihelion and aphelion distances are 9.195 Australian dollars and 9.957 Australian dollars, respectively. Similar to Jupiter, Saturn has distinct rotation periods attributed to various areas, and the visible features rotate at different rates depending on latitude. Thanks for watching. If you liked the video, please like and share it. Your support will help the channel expand, allowing me to continue producing content like this. If you're interested in learning more about the other planets in our solar system, check out the channel.